Hey everybody, Mr. Morrell here, and today in this video we are going to we are going to squeak as we make a video. I'm not even going to edit that out. You guys get it. But in this video we're going to talk about the multiplicative properties of regular numbers as a review, but also we're going to start diving into matrix stuff. Now, keep in mind, we're not really departing from the stuff we did. We're building to eventually connect what we're doing in class with matrices. So one of the ways that we're going to be able to solve a system of equations is with matrices, but it's going to take us some time to get there, including talking about some of these multiplicative properties. Okay, so that's what we're going to do in this lesson. But before we do, let's just do a really quick reminder about the additive properties from the last homework assignment. So an additive identity and an additive inverse. An additive identity is a number that doesn't change the value when you add it to another number. An inverse means that you would add an inverse to a number and get the identity back. So just a really, really quick refresher. So the additive identity of A is the number 0 because A plus 0 is just A. The inverse means that we're trying to get to 0 when we start with A. Look at those beautiful numbers. So A plus something would be 0. And again, in the last video, we talked about how that would be negative A. All right, so additive identity, pretty straightforward. Now, let's go into matrix land. Again, just as a quick review, same idea. We have additive identity on a matrix, means we're going to have a matrix that we can add to an original matrix and not change it. And adding is so simple that what we found out in the last lesson is we could add the matrix 0, 0, 0, 0. That doesn't change the value. So for the inverse, if we wanted to try to get to 0, 0, 0, 0, then what we would need to do is add the matrix negative A, negative B, negative C, negative D. Okay, really straightforward. Now, don't get too comfortable. Adding is going to be a lot different than multiplying. So let's go into multiplication land. And to help us get there, let's go to number, like normal numbers land. All right. So multiplicative identity, that definition is it's a number that when you multiply it by another number, you don't change the value of the original one. The inverse means that we're going to need a number that we multiply to an original number, and the result, the product, will be the identity. So that's probably a little bit confusing to start off, so let's just dive into an example. So what number can I multiply by A that doesn't change its value, just keeps it at an A? I'm going to guess that most of you know that right off the bat, that would just be the number 1. A times 1 is just A. It doesn't change the value. Now, some of you might be wondering, well, what would I multiply to get to a 1? That's a little tougher. Let me give you a simpler example. Maybe think about the number 2. 2 times something is going to get you to a 1. So just think about that for a second. What would you multiply by the number 2 to get to 1? 2 copies of something is going to equal 1. So you thought about it for a little bit. The correct answer is 1/2. 2 times 1/2 is 1. 2 copies of a half is 1. Really similar, you could think of, okay, 3. 3 times something is going to equal 1. What do you guys think it is? So we could do this like Dora the Explorer. So say it to the screen. And the answer is 1/3. And you could do the same thing with the number 4. 4 times 1/4 is 1. So A times something equals 1. The answer for that one would be 1/A. All right, so that's a multiplicative inverse. It's something we multiply to something else to end up at the number 1. All right, now we're going to go into matrix land, and it's not going to be as easy as the additive one, but it's going to be kind of cool and definitely important. So we can like look at our definitions. It's not that exciting. So obviously we need a matrix that when we multiply it to another matrix, we don't change the original matrix. And for the inverse, we need a matrix that's going to give us this identity thing we'll talk about up here. So don't sweat that for a second. Let's focus on the identity. So what if we just start with the original matrix 1, 2, 3, 4? I want to multiply that by something to end up with 1, 2, 3, 4. Now, anytime I teach this in class, Most kids, when I say give it a good guess, almost always the first guess that I get from students is 1, 1, 1, 1. Well, let's test that out. I'm going to go ahead and multiply. Now, if you are one of my students or if you've watched one of my videos, you know that I really like to multiply by dragging that first matrix down. My answer is going to fit snugly right here in this spot. And I know it's going to be a 2 by 2 matrix because this was 2 by 2. This one was 2 by 2. The outside numbers are 2 and 2. Okay. So if I continue on and start multiplying, remember we're going to start to get this number here. We're going to start outside numbers, multiply, multiply, and add them together. So 1 times 1 is 1, plus 2 times 1 is 2. So 1 plus 2 is 3. So in order for this to have worked, we would have needed that top corner to be the number 3, or sorry, the number 1, not the number 3. So I'm going to keep going with this because I actually feel like exploring a bad answer often gets us to the right answer. So let's find this next number. I'm going to start outside. So 1 times 1 is 1, plus 2 times 1 is 2. Okay, so now this is extra weird. We have 2 3s that showed up here. Okay, let's keep going. So now 3 times 1 is 3, plus 4 times 1 is 7. What? I mean, is 4. Add those together and you get a 7. Okay, this one over here. 3 times 1 is 3, plus 4 times 1 is 4. 3 plus 4 is 7. So extra weird stuff going on here. I take my matrix 1, 2, 3, 4. If I multiply it by 1, 1, 1, 1, I end up with 3, 3, 7, 7 instead of 1, 2, 3, 4 that I want. So all sorts of kind of weird stuff is already starting to happen. Let me go ahead and erase the screen. And you may want to pause and try. I know that when I teach this in class, I'm going to have the kids do some guessing and checking. And in every single class, every year I've taught this, someone's been able to find it. So you can pause the video and see if you can figure out what would this matrix need to be. But what I'm going to do for the purpose of this video to keep us moving along is I'm going to tell you the matrix that would work here is 1, 0, 0, 1. And let's go ahead and test that out. So for this top left corner, I'm going to start farthest away. 1 times 1 is 1, plus 2 times 0 is 0. 1 plus 0 is 1. So we got a 1 in the corner. That's looking good because that's what we wanted over here. Now for this number, we're doing 1 times 0 is 0, plus, let's see, 1 times 0, plus 2 times 1 is 2, and that ends up equaling 2. Also a good sign, because we needed a 2 there. Okay, now this bottom one, I got 3 times 1 is 3, plus 4 times 0 is 0. 3 plus 0 is 3. Okay. Now, finally, this last one. Oh, and we had this one. 0 times 3 is 0, plus 4 times 1 is 4. 0 plus 4 is the number 4. So you could see that by multiplying our original matrix by 1, 0, 0, 1, we ended up with the same matrix. We didn't change it. So the matrix 1, 0, 0, 1 is kind of like the normal number 1 in normal world land. It's the number, it's the matrix that won't change things. So that matrix there, that's going to be a really important one to do, to show you. That's going to be the identity. So I'm going to prove that to you by just using the letters A, B, C, and D. Times by 1, 0, 0, 1. Let me slide this down, set up my answer. Okay. And I'll just run through this pretty quickly. So for this top corner, A times 1 is A, plus B times 0 is 0. So A plus 0 is A. Over here, this one, A times 0 is 0. B times 1 is B. 0 plus B is B. Down here, C times 1 is C, plus D times 0 is 0. C plus 0 is C. C times 0 is 0. D times 1 is D. 0 plus D is D. So we didn't change the value. Once again, the magical 1, 0, 0, 1 matrix. I love it a lot. So that's something for you to know. The multiplicative identity in matrix world is the matrix 1, 0, 0, 1. It won't change the matrix if you multiply it. Like, that's just going to be the way it is. Now, let's get into tougher territory for sure. Okay, so tougher territory, the inverse. We need to find a matrix that when I multiply this matrix by something, it should give me 1, 0, 0, 1. If I can find that matrix, that's going to be called the inverse matrix, and that's what we want. So instead of A, B, C, and D, let's just go to numbers because usually that's a little easier to manage. But what you're going to do on your homework is you're going to try to find the inverse. Now, on your homework, I have some guesses for you. So like it's worth thinking about what would this matrix have to be in order to multiply them to get to this. Now remember, let me skip back up here. Let's see. On our multiplicative inverse, it was A times 1 over A equals 1. And so, for example, the first matrix that you're going to be trying is, let's think, like I think a lot of students would want to do 1 over 1, 1 over 2. Sorry, that didn't look good. Maybe 1 over 3. This is a really good, like, natural instinct, a good place to start. But what you're going to find out on your homework is if you multiply these two things together, you're not going to get 1, 0, 0, 1. So you're going to have a couple of bad guesses because that's what happens. You guess and check stuff, but I had to find some way to get that on the homework. So you're going to run through some natural but wrong guesses. And then what we're going to do is over the next couple of lessons, I'm going to eventually give you the tools you need to figure out exactly what this matrix is going to be. All right. So that's our goal for the next 2 lessons. We're going to figure out what this thing is. To get there, we're going to need to we've got to learn some stuff in the way. All right. Thank you guys for watching. I hope that was helpful for you. Keep in mind the difference between an identity and an inverse. Those definitions, I know they're kind of boring, but they're going to be really important. Okay. Have a good day. Talk to you later. Bye.